In this tutorial, we'll learn about relational database design, including how to define relationships and ensure data integrity. In database design, an entity represents a real-world object or concept that we want to store information about, such as users, products, or orders. In a relational database, each entity is usually represented as a table. Attributes are the characteristics or properties of an entity. For example, a user entity can have attributes like user ID, name, and email, which describe each user. A primary key (PK) is an attribute that uniquely identifies each record in a table. It must contain unique values and cannot be null. For example, user ID in a user table ensures that each user can be identified individually. A foreign key, FK, is used to link one table to another. It is an attribute in one table that references the primary key of another table. For example, user ID in the order table can reference user ID in the user table, creating a relationship between users and their orders. Cardinality in a database describes how entities are related to each other. The main types are one-to-one, one. One record in a table is linked to one record in another table. One-to-many, one n. One record in a table can be linked to many records in another table. Many-to-many, n. Many records in one table can be linked to many records in another table. Normalization helps reduce redundancy and improve consistency in a database. In 1NF, we remove repeating groups and ensure atomic values. In 2NF, we eliminate partial dependencies, and in 3NF, we remove transitive dependencies. The overall goal is to avoid duplicate data and prevent data anomalies. Constraints are rules that enforce data integrity in a database. For example, not null prevents empty values, unique ensures no duplicates, primary key identifies each record, foreign key links tables together, and check enforces specific conditions on data. Indexes are used to speed up queries in a database. They allow the system to find data more quickly. However, having indexes can slow down inserts and updates, because the database must also update the indexes whenever data changes. An entity relationship diagram is a visual representation of entities, their attributes, and the relationships between them. It helps plan a database before implementation. For example, in an e-commerce database, an ER diagram might include entities like users, orders, order items, products, and categories, showing how they are connected. You've successfully completed the first part of the relational database design course. You've learned key concepts such as entities, attributes, primary and foreign keys, relationships, cardinality, normalization, constraints, indexes, and ER diagrams. Now it's time to take your design from theory to practice.